Bismillahirrahmanirrahim. Good afternoon, everyone. Today I will try to illustrate how I could solve this homework. I'm talking about the mirror, the concave mirror homework. Actually, let me read the question. It's important. You must know it for your exam. Determine the focal length for dental concave mirror according to the column below by using theoretically focal length experiment and experimentally focal length measurement. Okay, let me start from explain important thing. It's an important difference between concave mirror or mirror experiment and lens experiment. The longer distance at mirror is the distance between the object and at lens. The longer distance is the distance between the object and the lens. But the longer distance between mirror and the longer distance at mirror experiment is the distance between mirror and the screen. Okay, from where I know that by our life, when you will be dental, you will use this mirror to manage, test, to be sure if your patient have some cavities, some cracks, whatever. It's not my object, but here, from this idea, you will know the shorter distance will be between the mirror and the object. In your specialized, your object will be teeth. By that, all the dentists use this technique because this mirror, concave mirror, has this feature, the shorter object. Okay, this is important because in your exam, I use these two questions in your next exam. Okay, because it's a big difference between important difference between mirror experiment and lens experiment. Let me start here from the distance here. I said distance, not V. In mirror, you must know the distance that's mean V. Okay, V, S, T, whatever you want. Okay, S1, S2 in another source. That's depend on you. I prefer to use V and U like the previous experiment. Here D, that's mean V because now I'm talking about mirror, not lens. When I see D in lens, that's mean both of U plus V. Okay. Here, from the function equation, from 1 inverse focal length equal inverse V plus inverse U, we can simplify this function to be U multiple UV divided on U plus V. That's mean I need U plus V column, U multiple V column with centimeter square. And at last, I can use this last equation to calculate 5 times, to calculate the focal length to 5 times. Why? Because I have 5 recorders about U and V. By that, I have 5 results to the same focal length to the same mirror. By that, I will use the average function. Here I have 5.06 centimeters. That's mean the focal length is after the center of this mirror, after 5 plus 6.06 centimeters will be the converging point. Now, the theoretically it's done. Now let's go to experimentally focal length management. Here, at X will be U plus V from this equation. U will be U multiple V. By that, I can say, I can prove slope equal focal length. By that, let's calculate the focal length experimentally again and take a look if these are near from each other or not. Here at x-axis, I say every 1 centimeter equal 5 centimeter of u multiple plus v to be like that. By that, every 1 millimeter equal 0.5 centimeter of u plus v, and like that. X is done. Let's go to y. At y, every 1 centimeter equal 20 centimeter square of u multiple v to be like that. That's mean every 1 millimeter equal 2 centimeter square. Here, every 1 millimeter equal 2 centimeter square. And it goes like that. I have two irregular points. Last one is very near from the slope, but it's the nearest irregular point to the slope line. Here, from slope equation, I have experimentally focal length here, or let me say equal 4.44 centimeters. By that, the theoretical experiment, it's close from the focal experiment, focal length experiment, or experimental. The conclusion, it's the last step here. Relation between them is linear relation. That's mean its kind is direct. When one of them increase, the other one increase. Our results are near from each other. That's it. Thank you so much about your watching, listening. Have a good day and see you in the next video.